yet. And we hope that you will enjoy and benefit from today's webinar. I would like to thank as well our council member Dura-line in accepting our invitation to this initiative, and they led the way with three of special matter experts speaking during these two coming webinars, starting with today's subject on micro-trenching and one more session coming on 30th of July addressing fiber optic sensing. Our speakers today, Mr. Rick Dvorak and Mr. Jason Brabec. Mr. Rick is a senior solution architect, has worked for 12 years at Dura-line. Prior to that, he was at BellSouth and AT&T for 35 years and held a variety of positions during that time. He began his career as a cable helper for underground splicers and retired as a senior technical services manager at AT&T. I would like also to introduce Mr. Jason. Mr. Jason is a director solution architect, has worked for 2 months at Dura-line. Prior to that, he was the senior manager business operations at Verizon Communications. He began his career in 1997 as a network tester, was promoted to outside plant construction performing copper and fiber splicing, and in 2004 promoted to line and splicing Foreman. He began new organization for contract services and in 2017 was named Manager Construction National Staff. He holds an electronic engineering certification from RETS. He has been active in youth sports for 14 years focused on soccer. Mr. Rick and Mr. Jason, I'm incredibly happy to welcome you both today, and I believe I borrowed a few extra minutes of your time, so I will step aside and give you the full floor. Meanwhile, please, all attendees, we will have a time after our speakers finish their presentation for questions and answer. You can even enable your microphone or type in the chat area all the question you would like to ask. Thanks again, and please, Mr. Rick and Mr. Jason, go ahead.
All right, we do have a slide presentation. We're going to assume that everybody can read, so we're not going to read all these slides, but we'll talk through them if that's okay. Jason, are you going to control this or?
Yep, I'll go to the next one.
All right, okay. All right, so I've been involved with microtrenching in North America for 12 years. I first got involved with, I think, the first trial, but it was kind of a battle between Vermeer and Ditch Witch, who are the two popular manufacturers of microtrenching equipment. And it just, I was totally taken by the concept of going shallower and smaller rather than doing huge trenches with a backhoe and just, it's just an alternative method of installation, right? So, you know, you can, after a typical microtrench, you can drive over it. You don't have to close the traffic down for days. You don't have to come in and we call it plating, putting steel plates down to protect a trench while you open the road back up in the evening. It's just a lot less intrusive. So, all right, Jason.
Yep.
So, the physical idea of a microtrench, just basically it can be 13 millimeters to 76 millimeters wide, or up to 61 millimeters in depth. It's just depends upon, you know, what the agreement is, the requirement is from the end user and maybe the municipality. Municipality may say, no, I want it at, you know, 40 centimeters depth. I don't want you to go any deeper than that. One thing about working with municipality, you have to get their approval because it's, you know, there's in Europe, there's a lot more microtrenching. It's been going on for a lot more years. And so it's more commonplace, but still here in North America, end users have to work with the municipality, whether it's the state or the city, whatnot. The to get an agreement and saying, this is what our microtrench is going to look like. And this is the material we're going to use to reinstate the trench after, the microduct has been placed. And this is what we want it to look like. And there's a lot of things that you have to work with the city. If you don't, they can come back and say, no, you didn't do this right. You didn't do this correctly. Tear it all out. And you don't want that. So you want to make sure that they are on board. They're happy with the installation when it's all over. And that's what we're going to talk about. All right. Where can microtrenching be used? Just about anything you can imagine. So there's a lot of different reasons to place fiber. So everybody knows those reasons, but you can use it for just about anything. You can, and where can you use it? Some microtrenching is done behind the curb. Some is between the curb and the roadway. Sometimes it's right down the center line of the roadway. It just depends, again, what you've agreed to for the municipality. All right. So Dura-line has a lot of microtrenching products that we've developed over the years. There's more. We actually haven't listed all of these on this sheet, but these are just some typical ones that are used commonplace. You'll notice that top one, it's got 8 microducts, and so it can be put in a very narrow trench, put quite deep, or you can fold that actually in half and place it in a trench. So a little bit wider trench, but you don't have to go quite as deep. There's always going to be a requirement for a certain amount of cover that you need over the top of the microducts. All right. So if it's 20 centimeters of cover, final grade, then you have to figure out how deep you're going to go and what product you're putting in the ground. Correct. Again, we have flat configurations with an oversheath. You can put an individual microduct in a trench. That's kind of costly. I would always recommend at least a backup pathway, but there may be a requirement for just a single microduct, and it can go right to a residence or a business, and that may be all you need for for we call them laterals, branching off of a larger microduct system. So, and then we also make custom designs as well. It depends upon what the customer's requirement is. So, all right, Jason, go ahead.
Yeah, I think it's also important to note, just like Rick had mentioned, labor is usually the highest point, the cost point versus the material. So if you know that you need possibly 4 pathways at this point in time, but you're really not sure what you're going to need in 5 or 10 years down the road, the cost to increase as long as you can in the depth, especially in the top in the Dura-Flat or Future Path Flex model. That was very popular. It's still popularly used in the U.S. I know that my former role, my company, we placed a lot of footage, millions of feet of this in our larger cities. We also negotiated to be able to do that with our municipalities by offering them one of the pathways, and that was one of the negotiation points that allowed us to expand the network. So by adding more pathway, you're saving in the long haul, but then you are also offering, as a good corporate citizen to your municipality, your government entity, that you're willing to provide them with a little something for them, providing you with the opportunity to expand your network. All right, Rick, I'll move on.
All right. So the difference between traditional trenching and microtrenching is listed here. I've been in this industry a long time, and generally speaking, to place new conduit anywhere, it's going to take quite an excavation. It can be several feet wide. It can be even deeper. It can be directionally drilled. That's a little bit less intrusive, but there's really nothing that beats microtrenching as far as speed of deployment and, less impact for the customer and the the people living in the area. Right. I think this has to be in. Yeah, got to be in presentate full screen mode, I think.
Yeah, but it's not going to let me because this is uploaded.
Okay. All right.
Yeah. Well, let me see if I can share my screen here. I'll just pull that slide up individually, and I'll share my screen.
Okay.
Bear with us 1 minute, please.
But a very large customer of ours, they did the cost comparison, and the difference between traditional trenching and microtrenching, it was 5 times as long to do traditional trenching, and 3 times the cost. So that adds up after a while. You put in several kilometers of microtrench in a couple days, and it's compared to trying to do several kilometers of traditional trenching that could take as long as a month. That makes a big difference, especially in labor and impact to the community.
All right, it's Rick. I'm sorry. I'm just it's not going to let me share this. I'm getting some certificate errors. So basically, I can walk through it. I can walk through it on my screen and for the visual listen. So what's the difference between traditional trenching and microtrenching? Traditional trenches can be several feet wide, creating traffic detours for days or weeks at a time. Microtrenching, fewer road closures, can be driven over during installation. Planning to completion, open trench or directional boring versus microtrenching. You're looking at 160 plus days on a traditional open trench or directional bore versus microtrenching. You're looking at 50 to 55 days for completion. Surveying and permitting, usually your time is cut in half in compared to traditional trenching in the project. Manpower, fewer people needed to manage a smaller work area, less people required for traffic control, and smaller reels that are easier to handle. The cost of microtrenching creates a cleaner job. Microtrenching creates a cleaner job site with reduced backfill costs, faster installations, and lower restoration costs. Your build time, where you would be in traditional at 30 plus days, you could be sitting around 2 days, 2 operating days to complete your job. Traditional construction costs about 5 times in length and about 3 times in cost in comparison to microtrenching, where it's about 1/5 of the time and about 1/3 of the cost. All right, you can move to the next slide then.
All right.
There you go.
All right, so there's several steps, obviously, in any kind of a job. The planning phase, it's, besides determining the route, depth, and restoration, you want to make sure that the municipality knows what you're planning to do or what you're wanting to do. I've been on several visits with different cities and just talk to them about microtrenching, explain what it's about. And, they have hesitation sometimes, as any city would have. But after they see the installation and how clean it was and how low impact it was for their community, a lot of them approve it as, an alternate method of installing fiber cable. The trenching phase, it's just there's different equipment out there. In Europe, they have Marais machines. That's very popular. It's a French-made machine. Here in the United States, we've got Ditch Witch and Vermeer primarily. I know of a couple contractors that have purchased maraes here in the U.S., and they're using those to good effect as well. You want to make sure that your route is as straight as possible, and that's no different from any other installation, right? Especially if you're jetting cable. MicroDuct requires the installation of jetting method or blowing fiber into the MicroDuct. Those cables aren't really as robust as conventional cables, so they cannot be pulled. So you have to try to keep it as straight as possible. Straighter and the least number of bends is going to improve your distances. That's just standard whether you're pulling cable or jetting in cable. This is a typical setup for microtrenching. You've got a vacuum truck in the front. It collects the spoils, okay? The saw blade in the back, it's rotating and is set to the depth and width of whatever trench you're trying to put in. If you've got a 12 millimeter microduct you're trying to put in, you can't go narrower than that, obviously. So you have to have a little bit of room so the HDPE microduct or future path falls into the trench easily enough, and that you've got room for the restoration material. A little bit about the restoration material. You want to make sure that there's two things. It's got to be flexible like the roadway, because the roadway flexes with heavy traffic, and it also has to adhere tightly to the sides. You don't want a lot of water ingress. It maybe not in your region as much, but in northern climates, there's a thing called frost heave. And frost heave is where it gets down below freezing and water has snuck into the trench. It's gone into the trench alongside the reinstatement material because it's not, it's subpar. It's not what we would recommend. So water gets in there, it freezes. That freezing, as we all know, ice will expand. It actually pushes the reinstatement material out of the trench and causes problems. Pedestrians, bicycles can get caught in that trench after the reinstatement material gets pushed out. So, just have to take that into consideration if you have, or if you're installing in a region that, gets typically in the wintertime, gets freezing temperatures. You want to make sure that you are using a better reinstatement material, one that adheres tightly to the sides of the trench. Okay, pathway phase. You want to make sure that your route, the trench is cleared of moisture and cleared of any kind of debris, so that your pathway lays flat and smooth in the bottom of the trench. Okay. For turns, okay, there's a couple ways to complete turns. You can undercut, like this picture shows. You notice it's got a sharp point on the actual pavement, but they have actually dug around underneath that pavement or sidewalk to make a smooth transition, make a nice bend. The other way is to actually perform a cut, a 45-degree cut at that corner, so that you're making 245s instead of a sharp 90. MicroDuct's not going to bend like that. It's going to kink if you try to bend it at a 90-degree angle. So prior to reinstatement, and reinstatement is just the top level, what people are going to see and what people are going to drive over. You want to make sure that you've got it insulated. If you're going to use a hot bituminous mix to reinstate the trench, you want to make sure that the microduct is insulated. At about 248 degrees Fahrenheit, the microduct will start to soften. a hot asphalt mix or a bituminous heated mixture could be as much as 400 degrees Fahrenheit, and that doesn't mix well. So you have to insulate it in some manner, either with a foam backer rod that's made for that, it's heat resistant, or 1 inch of sand is sufficient. Sand has got a very good uh, thermal K value, they call it, and it'll protect that plastic below it very well. Here's a product that doesn't heat up. It's a two-part mixture. It's one of our favorites here in North America, and it's it adheres very well. It's very flexible. If I had a disc of it, a small disc of it, I could flex it enough, and you could see that it'll flex just as well as a roadway, but it's very strong. We've used it a lot in North America and works well. There's other companies that make similar products. So if, I'd say in the end, you want to make sure that your reinstatement material is high quality so that you don't have a failure there. Like I said, failures with your reinstatement, there's concrete mixtures out there that, or just plain concrete. It's not going to necessarily adhere to the walls of the MicroTrench very well. So, it could crack, it could come out in pieces, and then you've got problems. You've got maintenance issues, everything else. So you don't want that. All right. And the restoration phase, again, that's what I've been talking about. After you've dug your trench, installed your pathway, whatever it is, you want to make sure that you've put in a product that's going to last. And it's got to last at least 5 years. And, you can try different products. There's several different companies out that make really good stuff. And if, you want to do a field trial in, one of your facilities, you can do that, just several meters. You can try it and see what you like, listen to their sales pitch, etc. So here's another company that, there was one back here. GCP Applied Technologies was one. Let's see right there. All right, that's one that we like here. This is, there's sealers and additives that they can put and basically mimic the existing or the initial road surface before there was any cut. And you can see on this far right side, they've added some colorant basically, and you can hardly tell that anyone's been in there to install anything. We have a company in the western region of U.S., a GST Elephant Armor. Again, it's they've developed it quite well, and it adheres to the trench and stays in place. I wish I could say that, the magic is all in Dura-line conduit. We like it. We think it's the best thing in the market. But for a successful MicroTrench, it's all in your restoration, okay? And then you've got your fiber placing. There's a lot of different equipment companies out there to place fiber. You can get them to come out and do demos for you. Some of you may already have this equipment in your warehouses, or your installers are using it right now. I'm guessing that's probably the latter is probably the case, but there's no difference from in doing any kind of a micro installation. So it all takes high pressure air. While the machine just keeps the fiber moving into the microduct. What most of the work is done by the air pressure or the airflow over the cable. So whatever compressor you use is key. You don't want to use a small little electric compressor. That's not going to do it. You probably want a consistent air pressure of 120 to 150 psi or even higher. Now we have a brochure on microtrenching. We've got last year we did a microtrenching summit here in the state of Texas, and it was very well attended. You know, a lot of people had a lot of interest in it. It's become microtrenching in North America has become more commonplace. You know, when I first started getting into it 12 years ago, it was, you know, oh, nobody's ever heard of this, you know, oh no, we can't do this because it's not what we're used to. It's different. But now everybody knows about microtrenching, and it's, you know, it's a viable application in a lot of cities, a lot of states. We've got currently going on, the biggest microtrenching project is about 400 miles in the state of Pennsylvania, where Jason lives. And it's using our products, and it's along a highway.
Absolutely. And thankfully it won't be, it'll be microtrenching. So it won't disrupt too much of the traffic flow.
Right.
All right. Good afternoon, everyone. While we're on the subject of microtrenching, we thought it'd be a good idea to just kind of touch on smart city components. And obviously this is just going to address some of the higher level, or what I like to call the 10,000 foot level of what microtrenching can also provide. Governments and municipalities are always interested in data. And one of the things that microtrenching can help them achieve that is by utilizing your network that you put in. As long as they allow you to do this microtrenching within their city, they can use the pathway possibly that you have donated to them as a thank you for letting them into their right of ways. They can either, you know, lease those spaces from you, or you could possibly be selling them a service and collecting this data. But people always want to know what's going on, whether it's for an emergency, or they're trying to reduce traffic on certain roadways. If they want to monitor where most people are congregating, so that they can make sure that we have the proper bandwidth going to those areas. And obviously, the ideas are unlimited, right, for smart cities. So one of the things that I would like to put in the back of your minds as you think about the option of going into microtrenching, or maybe increasing your microtrenching abilities, is how else you can maximize your efforts with Pathway. If we go back to when we were talking about how many paths you need, 2 pathways right now, or maybe 3. But you're really not sure what the growth potential is going to be. But you obviously see that there's new buildings that are going to be going in. Talking to civil engineers within your government or your town or your city, you know that there's a new development project coming in. Maybe I do need to upsize while I have the okay to open up to do the microtrenching. Instead of putting in 3 pathways, I'm going to put in 6, or maybe you're going to put in 8. You know, the ideas are unlimited, right? And I just want to see you be able to maximize your labor cost and minimize any additional expense in the near future. There's the Internet of Things, okay, and the smart cities. I don't think I can walk down any street. It doesn't matter what town you're in, whether you're in the countryside or you're in the cities, where somebody does not have a smart device with them and they are connected. So we call it smart cities, but there's also smart towns and there's smart countries. If you look at farming, a lot of it is done where the farmer is no longer in their tractor. They're no longer in the fields farming. They have machines that are doing this, and they're controlled by the internet. And this is an option that is also where I try to say it's not just about cities being smart. It's about anywhere, the whole world being smart and being able to understand a lot. By 2050, 2/3 of people will live in cities, and this is going to put a strain on any city, especially the infrastructure. In 2017, more than half the world's population lived in cities. This has increased by 35% since 1920 to 2017. Eight million car accidents happen per year worldwide, 1.3 million traffic fatalities per year. If your city was smart, right, and this is one of the ways that you can sell us, if we've started to build these smart cities, think about how quick the reaction. You look at some vehicle manufacturers like Ford and GM, where they have OnStar, or they have some emergency response. Subaru has OneLink, I believe it's called. These are all different things that could integrate into a smart city, where instead of it being a fatality, okay, it could actually be somebody, unfortunately, that got injured but was able to be saved because help was able to be there right away. These are some of the things that you can provide as network suppliers and infrastructure builders, and then also things that you could help your city with as far as being a good corporate citizen. All right, that's really what I wanted to touch on. There's a few more slides on my presentation, but some of it is dated. Really, what I'd like to highlight on, and I touched on this a little bit here in Philadelphia. They save about $1 million per year in fuel and maintenance and labor for trash. So what they did was they hooked up sensors onto their dumpsters, and when the dumpsters were full, the ones with walking pedestrian traffic, instead of sending the truck around all the time to check the trash receptacle, it actually sends a signal back to say, hey, I'm 2/3 full, I'm half full, or I'm full and I can no longer compact. Then they send the truck out. So this has reduced manpower labor hours for the city, and then also greenhouse gases and the impact to the infrastructure and the roadway, because everybody knows when a trash truck is going down the small city streets, it does inhibit traffic flow. All right. I think that's all I have right now. Rick, do you have anything to add?
Well, I'd just like to add one thing. You know, there's
Sure.
a lot of talk about, self-driving cars and whatnot. It's very interesting that each car that's going to be self-driving, they're estimating it's going to take 7 gigs of memory and communication between, probably it's going to be a Wi-Fi platform for each car. All right, imagine a typical highway, what that's going to look like. I mean, that's a lot of information passing back and forth between vehicles and antennas. The only way to get economically to get those antennas installed, in my idea, is microtrenching. Otherwise, it's going to be a huge undertaking for every country if they get into self-driving cars. So, but yeah, that's all I have.
All right.
Mr. Jason, we have a couple of questions. I will start with a question from Mr. Tariq. Can subducting be used with the MicroDuct? What are the applications that suit this method?
Well, there's it's possible to, say you've got a 50 millimeter conduit in the ground and you've already got a fiber cable in place. It's possible to place a new pathway over that, place a new microduct, maybe 2 microducts over that, and have new pathways for additional fiber cables. It's very commonplace. We call it an override. You can take say a 50 millimeter conduit again and just put in empty microducts and subdivide it, or have multiple pathways. So you're not restricted to just placing one cable, but you can place additional cables as you need them. Again, that's still considered under the override, but it's really kind of a subduct type of application.
Okay, and we have another question from Mr. Sanjay. What is the flexible reinstating material called?
I believe that's the GCP Applied Technologies. It was formerly Sterling Lloyd.
Yeah, Sterling Lloyd was a company in UK. They actually developed that product for repairing bridge surfaces. As we know, bridges flex quite a bit, and that's what we first became familiar with here in North America. Now there's other companies that have followed suit and have similar products. That's what I was talking about earlier, is that it might be less expensive and more rapidly available to you in your region, but just make sure that we have a product here called Cold Patch. It's bituminous mixture, comes in a bag. You can get it at a hardware store. It's not hot applied. It's just you take a shovel, bust off a piece, and mash it into a trench. That's not going to last typically, especially with traffic rolling over it and whatnot. You're best to have an application, a product that's made for microtrenching. Okay.
We have another question from Mr. Prashant. Reinstate mooring monsoon months. Tutorial come out within 3. What is the good alternate? And why OFC is kept 1.6 meter below and microtrenching is not preferred always?
You understand that one, Jason?
Reinstatement during monsoon months and in the material coming out. Is that the first concern?
Reinstate mooring monsoon months. Tutorial come out within 3. If Mr. Prashant with us, can you please retype the question again in a different way? Okay, we can move until Mr. Prashant answered. We can move to the other question. Why OFC is kept 1.6 meter below and microtrenching is not preferred always?
That is key to working with the municipalities or the governments to make sure that they understand what microtrenching is. That, if their requirement is to put fiber cable at 1.6 meters, that's pretty deep. So microtrenching obviously won't go that deep, but they have to understand. They have to be educated, in other words, by the end user and say, this is what microtrenching is. This is how we're going to reinstate the trench. It's going to look just like new. When I was in the city of Chicago years ago, they wanted the incumbent company to repave the entire intersection every time they made a trench. This allowed the company, microtrenching allowed the company not to have to do that, and save them a ton of money, obviously, from not having to repave a whole intersection.
So basically, the monsoon means the rainy days in India. So the question is, reinstate material come out in 3 months in rainy days near coastal areas. What is the alternate for these materials?
Well, that's why it's important to have a reinstatement material that adheres very well to the existing roadway. In some cases, you've only got 3 or 4 inches, just a few centimeters of space above the pathway to install your final product. You don't want it to be something that's porous. You don't want it to be something where water can intrude down in there. Typically, these products don't float. Unlike the HDPE will float, but it's once you put that cap on it and you've got a good seal, it's just like the original roadway.
And I want to touch on a couple of things here. Microtrenching is one tool in your tool bag, right? It's one answer. It's one option to help deploy your network. It may not be the right method or solve for all problems or challenges that you're having with your network, but it is an option. But it does resolve a lot of issues or challenges, especially where you have tight real estate in the right of ways, meaning you don't have a lot of space, but you need to deploy some of these. You need to deploy your network. It's important to know that you can go smaller into the micro world and actually reach the same capacity that you need to support your network. As far as the monsoon season, I used to live in Hong Kong and East Asia, so I'm very familiar with what you're referring to. It's a lot of heavy rains and floods and subsidence happens. Using the proper materials, sometimes you have to use the more expensive material because you know you'll be guaranteed, or very much undoubtedly guaranteed, that you will have good adhesion to your existing surface and roadway.
Right.
It's important for that. Maybe looking at other reinstatement methods. Okay, concrete does not stick to HDPE, so maybe using some type of concrete encasement would actually assist you in not having that issue happen.
Okay, so for the attendees who are asking about the full video, we will send it to all the attendees. We have another question. Is it suitable for core spine network as depth is very low and the protection is not there? The usual life for MT and W is about 3 to 4 years only. So is it suitable for core spine network?
So I think they're talking about long haul or backbone. Is that it? Rick, do you think that's referring to backbone?
Yeah. Again, microtrenching, like Jason said, is just a tool in your tool bag. If you've got a 3, 4, 5, 6 fiber count cable, if it would fit in a microtrench, maybe that's not the best application for it. Maybe you do want to go, a meter or two deep to help protect it. But that doesn't guarantee, as we all know, there will be no damages. It doesn't matter if you went 20 meters deep, somebody's going to eventually dig that deep and damage your cable. But, for less sensitive installations, maybe not for a military base, but maybe for, it's just DAS antennas or, fiber to the home. That's certainly a viable option to use microtrenching and not be as deep. And in a lot of cases, that's actually safer, depending upon how congested the existing infrastructure is. If power is at, a meter and a half, they're going to be, there's going to be a lot of construction around that, water, gas, all that sewage. So in a lot of cases, the microtrenching is above all that, and as long as it's marked and everybody knows that it exists there, then your fiber's gonna be just fine in a shallower trench.
Okay, so sorry, go ahead, Mr. Jason.
Okay, no, that's all right. Just how long it will last will depend on how it was installed, right? So if you installed it to the requirements, and it's not to say that somebody doesn't accidentally dig up your facility, or it's missed, or there's something that's an active nature, okay, that causes damage. You can easily repair your microducts. The accessories that we have, pretty much all that require you is to have a duct cutter that you can cut the pipe on either end with a nice flat 90-degree cut, and then it's just push connect or push lock for the couplers on either end, and then you're done. So you don't need any special tooling other than the accessory, which is the coupler, and then also to purchase a duct cutter. But it's going to be the same duct cutter you're going to use for any other micro product that we provide. So it's not. We try to give you all the accessories, but so you don't have to carry 30 pounds of tools on your back every time because you're not sure what situation it is. MicroDuct all have very similar tooling, So that way it keeps it easier on you. So you know what tools to bring to do a repair.
All right. So Mr. Muhammad is asking, kindly advise if we use enclosures TYH in MicroDuct solution.
Well, typically there might be handholds or vaults between locations. Certainly a closure can be used. It's not going to hurt it. We don't typically offer that because it's the couplers themselves are airtight and watertight to 200 psi. So the coupler itself with a O-ring seal is what seals out any debris, dirt, water. But certainly a closure could be used. In some locations, they opt for a closure rather than a vault, and just have those locatable. You might put an electronic marker ball over that location just so that if you ever have an issue, you know where to find it later.
Okay. How much is the speed of MT machine for various situations?
You can go a kilometer, 2 kilometers with the microtrenching crew a day. Just depends upon how many turns, bends. If you're going right down along the side of a road, there's not a lot of intersections or other things to deal with. 2 kilometers isn't unheard of. And that's just for the cutting, right? So the crew that's coming into reinstatement has to be able to keep up. So, with the reinstatement material.
Yeah. Mr. Paul, he said maybe we should review depth of microtrenching and why it is more robust now than in the past.
Well, I think it's always been a robust solution, the microtrenching, but it's just sorting out the reinstatement material, like I said earlier. You can go for reinstate for, say, for instance, $1 a foot, or you can spend $10 a feet per foot to reinstatement. Now, if I'm not, educated, I'm going to say, oh, the $1 a foot sounds great. But then next season, I've got to come back and repair it or recover it with a $10 a foot product. Then I haven't saved any money, right? All I've gotten is customer complaints and issues with having to come back and do it all over again.
And I think too that the technology and the machinery itself, the installation equipment themselves, they've really come leaps and bounds from what they were years ago. So now it's becoming more accepted, not only by the industry but also by municipalities and government operating entities.
And all the trenching companies, they are, constantly working with their R&D to extend the life of saw blades and, custom depths and new machinery to get into tighter places. And they're, it's a full-fledged industry now. So.
Okay, so Mr. Iyad, he said, we have had situations whereby during microtrenching, you come across sewer lines, hard rock, and eventually you break the driller. Is there a situation this can be avoided, maybe with the new jumbo future path and our corrugated ducts?
Well, in a lot of cases, your depth on your longer roadway is going to protect you from getting down into, say, a rocky soil or whatnot, because basically all that excavation has already been done for you. That's part of putting it into the roadway, is that you got the roadway as your protection. I know here in North America we always send out our road repairs to the lowest bidder, so it's not always the best material and the best, product that's available out there. But typically it can be up to 2 inches of the surface removal, and then they come in and repave. So you want to have your at least the MicroDuct below that, so it's not going to be damaged when they come in and resurface. That's always a consideration, in some cities and some locations.
When you call in, I know in North America we're big on our locating of existing facilities. Each facility owner is responsible for that. I'm sure there's similar responsibilities in Europe and in the Middle East, but maybe just understanding where they are. I know that there's a couple of different ways you can do that. We can call in a design locate, which will provide you with information as far as where the facility owners say that their equipment or their facilities are, or they maybe provide you with a mapping to show you where they are from crown of road or from curb of road, so that you can do that's part of that planning phase. I know that I used to work closely with the roads department of not only the states and counties, but also into the cities that I knew that we were going to be requested to place a lot of pathway. And I would find out when they plan on remilling the roads and paving the roads. If you get a paving schedule from them or where they're going to build new road construction, you can kind of gauge when you will need to have your crews and place your pathway. So that way, once they have completed their milling, where all your facilities will be identified, hopefully for you at that point in time, plus any subsurface substrate that may be there, you can go ahead and place your pathway. And then when they reinstate the road, you don't have to worry about it because the road has been completely reinstated by that city or government entity. So that's another way that you could, again, partner with your municipalities and your governments to say, we'd like to expand our network. We know that you don't want us tearing up your roads, or we don't want to get into, excavating on your brand new paved roads. Where are you planning on paving or creating roadways in the next 6 months or 12 months or even 2 years? So that way you can start to plan how you want to expand your network and what method you use, whether it's micro-trenching or it could be standard pipe, or it could be jumbo pipe, future path, which could provide you with a multitude of pathways within a very small real estate space in the underground. There's many, many different options that you can look at.
And one thing we kind of glanced over was, all of our products can be made with an internal locate wire. For those of you familiar with locating, you put a signal on one end of that wire, and there's a locate device that can identify precisely where the copper wire is, which is going to identify where your pathway is. Most of our cables for microducts are non-locatable. They're all dielectric, so you need to be able to, even after they put an additional surface of blacktop or tar or whatever they do in your region to put a new surface on the roadway, you have to be able to locate your pathways. So all of our products are available with the copper locate wire.
All right. So can you discuss on how to repair and restore micro-trenching in case of accidental cut?
If you had an accident, you've got a damaged microduct or damaged pathway, or you suspect you've got a damaged pathway, you'll have to dig that up with mechanical means again, and you can there's none of with HDPE pathways. There's not very many different products that stick to that, so you can break away the reinstatement material. Like Jason said, you take two microduct couplers. You take a short piece of microduct and replace and splice that out, and then you restore it with probably the same material that you used for the initial installation. If it's got a damaged fiber, you're probably going to have to replace that fiber after you've repaired the microduct.
All right. So Mr. Sanjay, he said, I believe that North American market is predominantly a subduct market 40 millimeter plus. Can microtrenching work with such ducts?
Yes, you can have microtrenches up to 3 inches wide, actually. In fact, one of the largest companies, one of the largest contractors that do microtrenching in North America, they add additional blades to the saw so that maybe instead of just one circular blade, it's got 3 blades altogether, and they're able to go up to 3 inches. So they can put larger conduits in there, larger bundles of microducts into a trench, and as well they can go up to 24 inches deep. It's more of a saw cut than microtrenching. It's more, some people call it macro trenching, but it's, there's a lot of options out there. You just have to check with your installers and see what their capabilities are.
All right. So Mr. Paul, he said, has microtrenching improved over the years over shallower trenching? While it is only a tool, is it robust enough for most applications now, like smart cities?
Absolutely. Last year when we had our microtrenching summit in Texas, that was the goal, was to help educate municipalities. We had several cities attend, a lot of end users, and just to help educate them with the advances and the changes in microtrenching. There's some companies that may have tried microtrenching 10 years ago, and they discounted it because it wasn't going to work for them. But things have changed, and so we had vendors involved, and they were able to show their products, and it was very educational for all involved. That's I think that's key for everybody to know what to expect from microtrenching, and how it's done and what products are used.
Okay. What is a typical depth and width for a microtrench for you?
It can vary depending upon what the requirements are. So, if we went back to that one screen here showing some of the different microtrenching products right here. This 8-way product at the bottom, it's probably an inch and a half, or it's probably a lot larger product to fit in a microtrench. So, you want to be able to have enough room in your trench to be able to cover it properly. If you're going to use a hot reinstatement material, you want to have room to insulate it with at least an inch of sand or similar over the top of it. And, it's just, it depends upon what your requirement is. If you want to place a 48 fiber, you can get by with a lot smaller microduct. If you're trying to put in a 432 fiber, it's going to require a larger microduct, obviously. So you'll have to look at the dimensions of the products that you want to install and the requirements of how much reinstatement you need. And again, the municipality or the city or state may require, a certain amount too. They may have their opinion of what they want to see.
Yeah, I can't agree with Rick more. Really, you need to look at the size of the facility or what you need to provide, which will dictate the size of the pathway that you're going to need to be required to place, which is going to dictate the size of your trench. And then usually the depth of the trench is going to be dictated by your government entity or right of way.
Okay. So, Mr. Paul Dickinson, he wrote that my understanding is that microtrenching now with nice depths and better adhering reinstatements materials is more robust than in the past. While not suitable for all applications, the technology has significantly improved to the point it can reliably be used for many applications, such as smart cities, roadways, etc. My understanding is that microtrenching in combination with microducts is very cost effective and fast with much less disruption. Combining this novel installation technology along with microtechnology along with fiber optic sensing can provide added value to the customers. Please register. All right. So he is talking about the next webinar. Sorry.
It's quite all right.
But we couldn't agree with you anymore, Paul.
Absolutely.
It's. I think you'll see, in the next couple of years that microtrenching will be deployed all over the world for an economical and to increase bandwidth everywhere. So it's all about bandwidth right now. Any other questions?
So I guess that's it. Some of the attendees, they asked for your emails, and I guess Mr. Yogesh provided emails. And Mr. Shukri and everybody, they were send their thanks to the valuable topic and valuable, let's say, webinar. At the end, I can only thank you both for this informative webinar and for your time, and we hope all the attendees enjoyed it and learned as much as I did today. Looking forward to welcoming you all on our next webinar with Dr. Paul Dickinson, who attended also today on the 30th of July, talking about the fiber optic sensing. Till that time, thank you very much. Stay safe, and looking forward to welcome you all next Thursday.
Thank you all.
Thank you.
Thank you also to the council for inviting us and having us. We look forward to more opportunities.
Our pleasure, sir. Thank you very much.
Bye-bye.
Thank you.
Bye.